Okay, welcome back to section 2 of chapter 10, quadratic functions. Our first essential question was, how do you graph quadratic functions y equals ax squared plus bx plus c? Our second essential question is, how do you graph quadratic inequalities? When you're done copying that down, go ahead and turn over to the last page of this section. We are only taking one page of notes today. Okay, we are starting off with a real-world problem. A ball is thrown into the air with an initial upward velocity of 48 feet per second. Its height h in feet after t seconds is, then here's our equation. This is the velocity equation. If you notice, here's our 48 from the 48 feet per second. This plus 4 is the height that the ball is thrown from. So this person is throwing the ball from 4 feet off the ground. And then the negative 16 is a part of the velocity formula. Okay, A, how many seconds will the ball reach its maximum height? Before we answer that question, let's analyze this quadratic function a little bit. Okay, looking at our function, let's see, so we have y equals ax squared plus bx plus c. So our a is telling us it's negative, so it's opening downward, which makes sense because the ball would be thrown up, ball goes up, it comes down. The 16 means that this throw is pretty wide. Now the B, the axis of symmetry, we learned about yesterday. So that would have to do with our B right here. That formula, let's go ahead and just figure it out just in case we need it. Negative B over 2A. So we have negative 48 over 2A, so that's 2 times negative 16. Which is 1.5, negative 48 divided by negative 32. So that means that our axis of symmetry is 1.5. So the x value of our vertex is 1.5. Okay, and the C means if it's moving up or down, our vertex. So, well, our graph obviously is moving up. So I'm just going to put an arrow since it's positive. We are not throwing this ball from below the ground. Okay, let's look at A. How many seconds will the ball reach its maximum height? Okay, since we're looking for seconds, we want our x value. Because on our graph, I'm just going to go right on top of this one that we already drew. Throws the ball up. So that means our y-axis is the height. And our x-axis would be the seconds, how long it takes. Okay, we had said earlier that our maximum height would be our vertex. Our vertex meets up with the axis of symmetry. And we also figured out earlier our axis of symmetry is 1.5. So, how many seconds will the ball reach its maximum height? After 1.5 seconds. And I'm just going to draw an arrow right here to remind myself when I look back at my notes, this is where the 1.5 came from. Okay, what is the ball's maximum height? So we're looking to see when the ball reaches this point right up here. After 1.5 seconds, how high will that ball be? We just plug the 1 and 5 tenths into our formula. So we want to know the height, negative 16 times 1 and 5 tenths squared, plus 48 times 1 and 5 tenths, plus 4. Go ahead and solve this down. When you are done, you can check your answer up on the screen with mine. Okay, I got 40 feet. So that means after 1.5 seconds, our ball will reach its maximum height of 40 feet. If it helps to draw the little graph like we did up here, please do so. Especially for the first couple problems on your homework assignment, it may be useful to draw that picture. Okay, graphing quadratic inequalities. This is the exact same as if we were graphing functions or lines. So a dashed curve means that it's greater than or less than. A solid line means that it's greater than or equal to, or excuse me, less than or equal to, or greater than or equal to. You shade below if your function is less than x, or, oops, this must be an or, less than or equal to x, and you shade above if your function is greater than x, or greater than or equal to x. For example, I have graphed the quadratic function x squared minus 3x minus 4. Notice how we have shifted down 4. There's our y-intercept. And it's a solid line because of the or equal to. Since it's less than, we shade below. You can either shade like this or you can go horizontal, whatever is easiest for you. Okay, that's it. That's our lesson for tonight. Go ahead and write your summary. The homework when you get to class on Monday will be page 560, 15 through 22, and then 36. We will also have Book It on Monday, so our amount of time for homework will be shortened a little bit. So if you want to do a couple problems this weekend, that would be awesome. Okay, we will see you Monday.